Hello guys, welcome back to my channel. In today's video, we are going to talk about UDP protocol. In the last video, we talked about the TCP and also we covered how the protocol makes sure that everything you send over the internet arrives safely and provides a reliable communication. We understood that the TCP is a reliable communication protocol. If you haven't watched that video, I recommend you to watch the video first, then it will make today's topic even clear. Okay. Let's move on to the UDP. Okay. At first, you might think it works as the same as a TCP, right? Since the both protocols belong to the transport layer. But here's the thing, UDP doesn't wait for any acknowledgements, there is no handshake and no delivery confirmation. And also here the question is, if the both TCP and UDP helps us communicate, which one should we use and when should we use? Okay. So that exactly we are going to cover in today's video. By the end of this video, we will understand what exactly the difference between the TCP and UDP and which protocol is best for different situations. Okay. So please make sure that watch the video till the end. It's going to be fun and super useful. Okay. Now let's look at the today's agenda, what we are going to cover there. First, we'll start with the introduction to UDP. Then we'll cover UDP header. And then we'll understand how UDP works taking the real-time example. Finally, we'll cover the major difference between TCP and UDP. So that's all about the today's agenda. Okay. So without wasting any time, let's get started with our first topic, introduction to UDP. Let's understand what is UDP. We all know that UDP is one of the protocol in the transport layer. We do have the two protocols, right? One is TCP and one is UDP. It is a connectionless protocol because there is no handshake or session setup before sending any data as TCP uses. UDP focus on more speed and simplicity and also it is low overhead, but it does not provide any reliability and also it doesn't provide any guarantee. It does not care about the order of the packets and it does not handle error recovery too. But then what is UDP here? UDP is simple. It's collect your data, add a small header and send it to the receiver. It doesn't care what happened to the data, whether it reaches successfully or arrives out of order or gets corrected. Even the receiver receives the data, that sender never knows that. Okay, that is the UDP. The UDP is just pass your data and send it to the over the internet. Okay. Let's take a general example to understand how UDP works. It is a general example. This example I use in various situations like different concepts like network topology. I use the same example. Okay. Imagine you wanted to write a letter to your friend. What you will do? You will simply write your letter and you will add the friend's address to the envelope and drop it to the post box. So once you send it, you don't know whether it will be delivered, lost or delayed. There is no confirmation, there is no tracking and there is no guarantee too. So that's exactly how UDP works. It just sends the data, it doesn't care about what happened next. Okay, I hope you understand what is UDP. So this is a simple introduction to UDP. Now let's look at the another topic. What is UDP packet header? Okay, for every protocol has protocol header. Okay. So in UDP packet has a very small header, just 8 bytes, which means 64 bits, I guess. Okay. So the UDP header contains only 4 fields, that is source port, destination port, length and checksum. If you observe in the TCP, we talked more TCP header, right? So but these fields are much simpler compared to TCP. Okay. Without wasting time, let's discuss each field one by one. Okay. Remember, before understand about the UDP header, just remember each field has a 16 bits, which means 2 bytes. Okay. So the first one is source port. What is source port here? The source port identify the port number of the sending application. So this helps the receiver know where the sender to response if there is a response expected from the receiver. Okay. Suppose you send a DNS query. Your machine will use a random port as a source port. So when the DNS server replies, okay, it sends the response back to the same port. Okay. So if the no reply is expected from the receiver, the source port can be set to 0. Okay. If we put in simple terms, if a response is expected from any application, a random source port generated. If no response is expected, the source port may be set to 0. Okay. This is all about the source port. The next one is destination port. What does it do? This port identifies the receiving application. Okay, if you put in simple terms, it tells the receiving system which process or service should handle the incoming data. Okay, let's take example and try to understand it. If you make a DNS query, for example, okay, the destination port will be the known port, that is which we use port 53. Okay, if you connect to a DHCP server, then the destination port will be 67 or 68, depending on whether it's server or client. Okay, so for other services like online games or streaming, the destination will be depends on the specific application. They mostly use custom ports. Okay, so all we can say that destination port identify the port number of the receiving application. Okay, so we understand what is source port and what is destination port. These two ports used for make the communication happen from the source and the destination. Okay, so the next field is length. What is length here? Okay, this particular field specify the total size of the UDP packets in the bytes, which means both header and the data together. Okay, the minimum value is 8 bytes if there is no data, just the header. The maximum value is 65,535 bytes. Okay, so for better understanding this length, let's take simple example. If you send a DNS query with 20 bytes of data, the length will be 20 bytes data and you should add the header, that is 8 bytes. The total is 28 bytes. So basically this field defines the size of the entire UDP packet. Okay, so this is all about the length field. Now move to the last field, that is checksum. What is checksum here? If you remember from the TCP header, we also had the checksum field. The function is the similar in the UDP. It is also used for error detection. Okay, so the checksum in the UDP covers the both UDP header and the data payload. How it is calculated? Okay, how do we find the errors? Okay, it uses the simple formula. Okay, that's a ones complement sum of the all the 16-bit words. So when the receiver get the packet, it recalculates the checksum. The calculated value matches, then the data is accepted. If it doesn't match, the packet is discarded. Okay, let's put in simple terms. So the sender calculates the checksum and place in the header, that is checksum field. So as soon as the receiver receives the packet, he checks again. If it is matches, that's great. If not, the packet is thrown away. Now let's understand the difference between the TCP checksum and UDP checksum. In TCP checksum, if the checksum fails, right, the packet is retransmitted because TCP cares about the reliability. The sender will wait for the acknowledgement. If the sender doesn't receive any acknowledgement, you will retransmit the packet. Okay, so in the UDP, if the checksum fails, the packet is simply discarded. No retransmission. The sender might assuming that the particular packet received by the receiver. Okay, so that's all about the UDP header. It is very simple header. Now we'll examine the UDP header in the real packets. For that, let me open website, that is UDP header Cloud Shark. Let me open first website. Yes, it's loaded. Now let me open the UDP packet here. So whatever we discussed the fields, here you can see the same fields. Here the first field is source port. This can be generated by the random number and the destination port, which is received port number, and the length is the total length of the UDP header plus payload, and here you can see the checksum. Okay, so the checksum value will be stored in the checksum field. Okay, so this is all about the UDP header. Okay, now let's understand how UDP works in the real time. So far, like we understand that what is UDP and what are the fields in the UDP header. Let's imagine you're trying to access a website in your browser. As all we know that your computer first send a DNS query. So the DNS uses the UDP. Okay, the reason is because of millions of queries happens every day. If the DNS uses TCP, right, we would see the latency issues and delays. If you want to open any website, it will take too much time to open the page if you rely on the TCP or if you use the TCP. That's why DNS typically use the UDP for fast response. But in some cases, TCP uses. When do we use like a DNS zone transfer? When the response is too large, that time the DNS will switch to the TCP. But for the standard queries, we will always use the UDP. Okay. So here what's happened? Okay. So you are trying to access a website. Your computer send a DNS query. Okay. Then UDP adds a small 8-byte header with a random source port and the destination port will be 53. Okay. That is a DNS port number. So the particular packet is sent across the internet without any handshake or acknowledge. Then the DNS server receives your query, process it and send back to the same port. Okay. So but here the important part is the packet is lost or unreachable. You won't even know that what happened because UDP does not provide any acknowledgement or guarantee. Okay. That's how UDP works in the real time. Okay. So now look at the important concept. Okay, this is the final topic. That is the difference between the TCP and UDP. So this is also frequently asked in the interview question. Okay. So let's understand the difference between the TCP and UDP. We all know that both TCP and UDP belong to the transport layer of the OSI model, but they are designed for different purpose. Okay, let's understand one by one. So the first one is connection. How do we connect to the servers? Okay, so the TCP is a connection oriented. It is establish a three-way handshake before sending any data. If you don't get acknowledgement from the server, the TCP doesn't even send any more data to server. It doesn't even start the connection. Okay, that UDP is a connectionless. It just sends the data without any handshake. Okay, that is a major difference. Okay, it just flood the packets over the internet. It doesn't care about that whether the packet is received by the receiver. It doesn't wait for acknowledgement. It doesn't provide any guarantee. So that's why we call it as a UDP is a connectionless. The next one is reliability. The TCP is a reliable protocol. It guarantees the delivery, retransmit the lost packets, and also ensure that the packets are received with the correct order. Okay, so this makes TCP a reliable protocol. UDP is unreliable. There is no guarantee, no delivery. There is no guarantee of the delivery, no transmission, and packets may arrive out of order. Okay, so this is the second difference between the TCP and UDP. The third one is acknowledgement. In TCP, each and every packet is acknowledged by the receiver. Then only you will send the next packet. Otherwise, you will keep retransmit the packet, whatever the lost packets. Okay. So with UDP, there is no acknowledgement. The sender never knows that if the data was received or not. Okay. So the next one is speed and overhead. Compared to UDP, TCP is a slower because it has a lot of process like a handshake, acknowledgement, and retransmission, and also it has a large header, 20 plus bytes. Obviously, it will be slow. Okay. So the UDP is a faster, lightweight with a very small header of 8 bytes. Okay. Then comes for a error handling. How both protocols handle the errors. The TCP handles both error detection and correction. If any packet is corrupted, the TCP requests a retransmission by using checksum. UDP also has the error detection via checksum. But if any packet is corrupted, right, it's simply discarded. There is no correction or retransmission. Okay. Finally, use cases. This is very important. When do we use TCP and UDP? Okay. So TCP used where the reliability is important. So where guarantees are required, like the web browsing. Let's say if you want to access any web page, like it use HTTP, HTTPS, and then email, file transfer, and remote login like a SSH. Okay. So wherever the guarantees and the reliability is required, the TCP will be used. Then where do we use UDP? UDP is used where the speed matters more than reliability, like a DNS queries, online gaming, video streaming like a Netflix and Hotstar, or live broadcast such as our favorite game, cricket streaming. Okay? So this is all about the major difference between the TCP and UDP. Let's quickly recap. TCP is a reliable, connection-oriented, order-delivered but slower. UDP is a fast, connectionless, lightweight but unreliable. Okay, so this is all about the difference between the TCP and UDP. So that's all for today's video. I hope this gave you the clear idea about the difference between TCP and UDP. Where do we use these protocols? Okay, I will be back next with another exciting topic. Until then, take care. Bye bye.